In this video, we're going to dive into the new concurrency system introduced in Swift 5.5. Now, this is a ridiculously large topic. In fact, it's not even fully released yet in Swift 5.5. It's so big, it's going to release over multiple Swift versions. I say that just to give you the context that you're not going to know everything about Swift concurrency and the new async await system and all the stuff you can do with it in this iOS 15 update section. Like, this could be an entire course in and of itself. So just to set the expectations there. However, how I decided to structure this section is to give you a big overview on what this new concurrency system is, the plan for how it's released, like why is it even happening, and then we're going to refactor our existing network calls in our GitHub Followers app to utilize async await, and that will get you, touching and using the code and give you more context, because here's how I think you're going to learn the most with this. Because again, this is a huge topic, and I think if you just dove in and started watching WWDC videos without understanding async await, you'd be lost. But I think running through this, me giving you the big picture overview, and then you actually playing with some code and refactoring network calls, actually using async await, and then when you go do your deep dive into the WWDC videos or other content, you're going to have all this context and you're going to get a lot of value on your learning, right? So I'm hoping this is the kickstart of you learning this big new concurrency system. That being said, let me point you to some resources on the history and the why, right? So here is a GitHub gist by Chris Latner. If you're not familiar with who Chris Latner is, he's no longer at Apple, but he was at Apple and a big part of the creation of Swift itself. So he put out this Swift concurrency manifesto, and I'm not going to read the whole thing, obviously. I'll do a quick scroll. It is insanely long, very detailed, very thorough. But if you're really curious about all this concurrency stuff, highly recommend checking this out. But this manifesto is just kind of illustrating their plans, their outline, what they want to do. And you can see it's broken up into parts. Part 1 is the async await. Part 2 is actors. 3, reliability. This is what I was talking about, how this is going to be released over multiple Swift versions, right? So I think in Swift 5.5, which was just released with iOS 15, we got part 1 and 2. So again, we're in the middle of this huge rollout, but I highly recommend checking out the manifesto. And then speaking of that rollout, here's a link to the Swift concurrency roadmap. So more of a plan on, how this will go. So like I said here, I'll blow this up a little bit so we can read it here. The introduction of these features will span multiple Swift releases. Features will be introduced broadly in 2 phases, right? The first phase, which was just released, introduces the async syntax and actor types, yada, yada, yada. The second phase will enforce full actor isolation, all the other stuff. You can read it. But that's what I was saying, is how this is so big that it's being released over multiple Swift versions. So this is going to take, a couple years to fully roll out. That's how big this new system is. But again, I highly recommend, reading through this as well. But have the context when you read through both the manifesto and the roadmap. This was written, as you can see, October of last year. So this is a year old before they really started implementing things. So maybe some of their, syntax examples might be slightly tweaked. Just to keep that in context, this was them illustrating their plan. So again, if you want the context, the history, here you go. And then I also recommend checking out, and obviously this will be all linked in the description. Here I'm at the WWDC 2021, and I just searched async, right? And these are all the async await or concurrency stuff that was released at WWDC 21. You can see there's a bunch of videos on it. Again, I'm just illustrating how big the topic is. And then I would start with this one, by the way, meet async await. That's kind of like the introduction. So if you are going to watch these videos, start there. But you see Swift concurrency behind the scenes, update a small sample app, right? Using async await and URL session. That's what we're going to do a little bit in our app. And then what's new in CloudKit Swift UI, because a lot of existing APIs like CloudKit got await specific functions for how to do things. So anyway, huge topic. Hopefully you're getting the point by now on that. But I'm going to link to all this stuff. Highly recommend going down this rabbit hole. It is going to be a big deal for Swift and iOS development. And again, what we're doing in this video, the update to this course, is hopefully your introduction to that rabbit hole, to that journey you're going to go on. All right, here we are in our code. And again, I'm just picking up on the project where we left off from the last buttons video. But this is our network manager, right? We've done this before. Hopefully it looks familiar. This is the existing way we did network calls, right? With the completion handlers. I'll actually make this a little bigger, right? Where we had to call completion handlers everywhere. A lot of code, right? So backing up big picture again, the purpose of this new concurrency system, well, maybe purpose is too strong of a word, but a couple benefits of the new concurrency system, because there's a lot going on, is that it's going to make your code easier to understand, right? All this code, as you know, maybe you were learning network calls for the first time, it is quite confusing. So one is to make the code easier to understand by implementing structured concurrency, whereas this is unstructured. We'll talk about that later, but that's a big thing. So anyway, the code is going to be easier to use. And then two, it moves a lot of the common errors into the language itself. For example, right, you notice we have to call completed everywhere this function can exit. Right? Completed. And if we don't call completed, let's say we just like forgot this, right? I'll comment it out. I won't delete it, but let's just say we forgot that. And if this error happens, we're not letting the user know, the app's going to hang, and it's up to us, the developer, to remember to do this, right? It's not forcing us to throw an error in this old way. So that's one potential error. And then remember how we have to like move things to the main thread manually, like that's taken care of in this new system. We'll talk about that later. But again, two of the biggest benefits are your code is going to be easier to understand and is going to execute in order. And a lot of the common errors are just abstracted away into the language to prevent us from making them. So that's the big benefit here. Okay, so here's how this is going to go down, right? We have three main network calls, right? We have get followers, get user info, and then downloading our image. So we're going to refactor all of these. So I'm going to really explain things a lot as I refactor this first one, and then maybe I'll go a little quicker on the second two because it's a lot of, the same stuff. But as I've said many times in this course, repetition is the key. But maybe if you want a challenge, right, we'll do the first one together, maybe pause the video and then try to refactor the second one, on your own, and then come back if you want to really push yourself. So in order to refactor this, what I'm actually going to do is for educational purposes here, right, I'm going to copy this whole thing, comment it out, and then paste it here. Now, the reason I did that is that way we can keep the old way just for like reference, right? So if you ever want to compare the new way with async await to the old way, you still have the code commented out. So again, that's purely educational purposes. So now that I have our get followers function copied, we're going to start hacking away at this, right? Really start chopping it down. So the first thing we're going to do here is this whole completion handler like way of doing things, that's out the window. So we're going to completely get rid of our completion handler. And instead of it returning that completion handler with the result, right, it just returns an array of follower. All right, if I go back up to the top, you can see that's what our result did, right? It either returned an array of followers or an error. Well, again, we're not messing with that. We just want to return an array of followers. But you may be thinking, well, how do I what if it's an error? Like, how do we handle that? So in order to make this function utilize the new async await, you got to mark it async like that. And then give it a throws because that's how we're going to handle our errors. So what these two keywords do is we're saying like, hey, this is an async function. We can use async await. And then this also throws. So it will throw an error. So that's the new function signature, right? Get followers. And then we pass in our usual parameters, right? We need the username and we need to know the number of pages. That didn't change. Except now we don't have a completion handler. We just say, yep, this is async. It is going to throw an error. And then in the success case, we return an array of followers. So now anytime we want to throw an error, we use the keyword throws. So here's an example, right? We want to make sure we have a valid URL, right? In the old way, we were calling the completion handler with failure case, and then the error was .invalid username. So here, instead of calling the completion handler, we're going to say throw gf error.invalid username. So very similar syntax here for this first part. But again, this is just making sure we have a good URL. But the purpose of this throws here, by marking it throws, is this solves that problem of making sure we have to throw an error. Remember what I said, a common error when doing this asynchronous code was forgetting to call a completion handler on every possible exit, right? Like if we didn't have anything here, we just had if let error returns, nothing would happen. The user wouldn't know what was going on. We wouldn't throw an error. So that was an error that could happen with the old completion handler way, right? It was up to the developer to remember to call completed at every possible exit point. Now that we've marked this throws, this is kind of like, it has to throw something, right? So there's no way we can have a situation where we forget to properly handle an exit. It's kind of like a catch-all. Catch-all is a good word because, you maybe have used throws before, but usually you use a do, try, catch block. And the catch is where you handle the error. So anyway, we're going to use that in a second, but we're going to go little by little here. So this was just the typical handling of the URL, and we don't need a return here because we are throwing. Now this task here, right, where we have URL session shared data task with URL and returns data response error. So URL session got a new awaitable method. So this is a new method here, but it will be similar. So it'll be let data, comma, response. So this is a tuple here, equals try await. Let me type out the line and we'll come back and explain this. Again, URL session dot shared. So this is the same code, down here, except now we do dot data from. And you can see it's marked async throws. That's the key difference. It's got to be marked async. Oh, no, it's data for. We want data from. So make sure you get the async one. Again, this is brand new in iOS 15, Swift 5.5. You can't use this in an earlier version of Swift. While I say that, let me be clear. The async await stuff requires iOS 15 and Swift 5.5. If your app still has to support iOS 14, you can still implement async await, but you have to have a lot of conditionals, like if iOS 15, do the async await stuff, else do the old stuff. And that just makes your code cluttered. You're better off waiting until you can support iOS 15 at a minimum. But that's the big thing here. Async await does require the latest iOS. So anyway, data from, that's async throws, and then the URL, which is what we have up here on line 61. Same thing, right? This is very similar to what we've done before. And then this delegate is optional. We don't need it. So now let me option click on this data here to pull up the documentation. So you can see it retrieves the contents of a URL and delivers the data asynchronously. The reason I wanted to show you this is to show you how I got that data response tuple, is because if you look, this is what it returns, right? It returns a tuple of data and response. And you'll notice they're not optional, right? That's the whole reason why you're using try and throws. You're not going to get back an optional. You don't have to handle the optionals, all that stuff. So this data URL response tuple is what we have right here, by why I said let data response equals try await, response. So what happens if this fails? That's why this is marked throws. So this will throw an error, based on this failing. So again, we're covering the exit pass with all of our errors. And that will be covered again in the do try catch block when we actually call this function later on. So like I said, that handles the error. So we don't need this. And that handles this data task, right? So we don't need this. And I'm just going to be like going down the line, like deleting stuff, because we are going to reuse a lot of things here. So like this guard let response equals response, we still want to do this. Now, again, this is kind of optional. Like if you wanted to check against response status codes, like 404 page not found, 500 server error. And remember, we just want to make sure we have a successful 200 status code. But again, if you did want to have a different error based on a 404 or based on a 500, based on individual status codes, this is where you would have a switch statement on the status code and handle them individually. Remember, we just did an invalid response. But again, instead of returning here and instead of the completion handler, we're going to throw the invalid response error. So throw gf error.invalid response. And then I'm going to line, this shouldn't be indented anymore. I'm going to line this up, once I'm done like messing with all this. And then here, we don't have to unwrap the data, right? This is us unwrapping the optional of the data, because remember, this URL session, this new one, it doesn't return an optional. You actually have the data. So we don't even need this line of code. So that can go away. So now we have our do try catch decoders, right? So now we have the data, which is the good JSON. We made sure we had the good response. And then now we're going to decode that JSON into an array of followers. Now, because we're going to use this decoder a lot, I'm actually going to refactor this out. And we could have done this before. By the way, this has nothing to do with async await. This is me just refactoring the code to clean it up. I'll let you know when we get back to the async await specific stuff. So I'm going to cut this decoder out here and put it up as another variable up here. And then in the init here, let me scroll down, we are going to give it the key decoding strategy of convert from snake case. We'll cut that, move that up here into when the network manager gets initialized. We're setting the decoder properties there. And then I believe there's one more on another network call down here. Yes, date decoding strategy. So we'll copy this and paste this here. And you'll see this is just so we can clean up our code a little bit by reusing the same decoder with the same strategies. Okay, so that was just a quick refactor. And to explain that, so when Network Manager gets initialized, it's initialized with a JSON decoder. And then in that initializer method, we are setting the properties of decoding strategy, key decoding strategy, and date decoding strategy to what we were using before. So that way, here in our do try catch, we just have the decoder ready to go. So with that, again, we don't need our completed anymore, right? The completion handler is gone. So what I want to return is the result of this decoder decode follower, right? So instead of let followers equal, I can do return and then, try decoder. And if the decoding fails, it goes into the catch. So what happens if the decoding fails? I want to throw, again, this is us handling the error, gf error.invalid data. Right, so we took that do try catch block, made it pretty simple, and then we no longer need this task.resume because we don't have the task. So let me highlight this all, do a control I to line that up. So now this is our network call now, and I'll run through it again real quick. So get followers, we're taking in the username again, taking in the page number, that was the same as we did. We marked it async throws. Async lets us know that we, are using the new async await. Throws lets us know, hey, this is going to throw an error because it's a network call, right? Bad things can happen in a network call. And then in the success case, we are returning an array of followers. Our endpoint is the same. We're just making sure we have a valid URL. If it's not a valid URL, we're throwing invalid username. Here on line 69, we're using the new share.data from. Again, this is new in Swift 5.5. This is the async version of it, and it returns a tuple of a data in response that is not an optional. And I keep saying not an optional because if we go back up here onto this line 32 here, remember this, these were optionals, data, response, error. Remember we had to handle all the optionals in our return. So that takes care of that. And then we are checking to make sure we have a valid response. Again, you might not have to do this, but we kind of did that before, so I kept it in there. And then I greatly simplified our do, try, catch. We're here, now that we have data, we are going to decode that data. And if it's successful, that's what we're returning, that array of followers. If it's unsuccessful, we're throwing the GF error invalid data. So that is the initial setup. If you don't quite get that, feel free to ask questions in the comments. Again, I understand this is a big topic, but hopefully after we've done this one and we've done 2 more of them, it'll start to click and you'll start to get it. So now let's go to where we call this function. Well, hold on. What's this? Cannot find base URL and scope. What did I do? Did I mess something up? That shouldn't be an issue. Okay, I'm probably missing a curly brace somewhere or a parentheses somewhere. No, okay, this is a copy paste error. I have an extra curly brace. That's what that was. That was a copy paste error from copying this whole function. So careful when you do that. And again, that's only because I copied this so I could keep that. So now let's go to where we are calling get followers. So we're doing this in the follower list VC here, and then we should just go to the error, right? So here, okay, this get followers function, right? This is what we need to refactor as well, right? Because here we're using the old network manager. And this is another thing, this whole weak self dance, you don't have to do that. And then, here we're presenting GF alert on main thread, or I believe when we update our UI, we're switching to the main thread as well. That whole switching to the main thread, weak self, this is part of what I was talking about gets abstracted away into the language, into the system itself, so we as developers can't make those errors. And let's talk about the main thread real quick. So certain things, again, in the system, like UI view controller, UI label, have been marked actor. Let me show you that and let's talk about that. So I'll scroll up here. I guess GF data loading VC. I'm trying to get to UI view controller, right? Okay, so I'm gonna option click on UI view controller and we'll go to the full documentation so it's easier to read here. So see UI view controller, right? And then you see it's marked at main actor. And again, that's new in Swift 5.5. And essentially what this does is if you're updating UI on something marked main actor, it automatically routes it to the main thread for you. So the super simple, just tell me what I need to know answer is that's how it handles routing to the main thread automatically in our network calls without us worrying about it. And again, let's go back here to our follower list VC. But if you want to do a deeper dive on actors, again, I'm trying to give you the big picture overview to not overwhelm you. Again, just know that actors are what routes it to the main thread for you. But again, the WWDC videos go deeper. There's tons of articles on it. I'm trying to keep this high level as your introduction to this whole new concurrency world. So now we need to refactor where we're calling this. But this is a good spot to show you structured concurrency versus unstructured concurrency. Basically what that means is the order things happen, right? So when network manager share.getFollowers, that gets called initially, and then the function exits. And then once this asynchronous call returns, right, our network call, because when you make a network call, it could take half a second, depending on the internet connection, right? The whole point is that it takes time. So what happens is this gets called and then the function exits. So step 1, call, step 2, exits, and then maybe a second later, step 3 happens where it comes back into the function, right? So the order of operations is 1, 3, 2, right? When you look at it vertically. So that would be unstructured, meaning it's kind of out of order of the way things happen. Whereas structured concurrency, which is what this new async await system shifts to, is so that your code can read top to bottom, and that is the order things are actually happening in. So that's where I say it makes the code easier to read and understand, because you're not jumping around in the order trying to figure out the flow of the code. The code just reads top to bottom. That's the order things happen. And again, that's structured concurrency, whereas the old way is unstructured because it's all out of order. Okay, so again, what I'm going to do is copy and then comment, because again, I want to keep it there just so you can, see the old way of doing things and compare. So Now, like I said, because our function throws, we're going to be in a do, try, catch block. And when I say our function, I'm not talking about this get followers here. I'm talking about the get followers in the network manager, right? This get followers, right, is async and throws. So because it throws, that's why we're going to put it in a do, try, catch. So back to the follower list VC. Here we'll go do, and then let me complete the catch here so I have it. So back in the do, we will say let followers, because if you look at our old code, in the success case, we get back an array of followers, right? And then in the failure case, we get an error. So this is the case where we get back followers successfully, right? So do let followers equals try await network manager.shared.get followers. And you see now our get followers function is marked async, as you can see right there. So that's what we want. For string is username, and then page is page. And where I'm getting that, by the way, is from our old network, right? If I uncomment this so you can see it, right? How we did network manager share.get follows for username for page. So that kind of function signature is the same, except now we're not dealing with the completion handler and weak self and all that. So let me comment that back. Okay, let me do a command B to clear up some of these errors. Okay, so this error, you'll see, says async call in a function that does not support concurrency. Now this is a big part, right? The function that does not support concurrency is this function here on line 82. That's the function we're in. This get followers function is not marked async. So it's like saying, hey, like I can't support concurrency. So a couple ways to handle that. We could restructure this function to support async. Not going to do that. A simple way to do that is to wrap it in a task here. So this task here looks like Swift UI code. Do that, and then now put the do, try, catch here. So what this task does is this puts you in a concurrency context, if you will. So here's where you can do your asynchronous code. So again, if you get that error that says this function does not support concurrency, whatever concurrency you're doing, wrap it in a task. Okay, so in the do block, this is like our success case, right? So we've successfully gotten followers from our network manager, right? If we were unsuccessful, right, if this try failed, we would go into our catch block. And this is where we're going to eventually handle errors. We'll get there in a second. So we successfully have followers. So if we go back and look at our old function here, what did we do in the success case? We updated the UI with the followers. Okay, so I'm going to update, and you notice we don't have to do self because we're not in a closure anymore. So I can do update UI with followers, and then I will also have to dismiss loading view. Now let me comment this back. I keep uncommenting that just to like show you the code because I know my comments are kind of gray and hard to read. So back to this, right? This is it's kind of like our success and failure case in the result. Where here we're getting followers from the async await, updating the UI, and dismissing the loading view. So cool. Now we have to handle what happens when this fails and we get various errors, right? And if I go back to the network manager, this could be the invalid username error. This could be the invalid response error. This could be the invalid data error, right? There's a couple different errors that we're choosing to pass back. And I'm setting you up for an example is why I say that. Because in our example, right, our product, we chose to show very specific errors, right? We want to let them know when it's invalid username. We want to let them know when maybe they're disconnected from the internet. We want to let them know when it's invalid data. Not all apps or situations like need to be specific with their errors. Sometimes you can just do a general could not complete your request at this time error, and then you don't have to deal with that. So the reason I'm saying that is because there's multiple ways to write what we're about to write based on what errors you want to show. So what we're going to write is going to look kind of long, and that's because we want to show specific errors. So I'll show you that way first, and after that, I'll show you how you could write it if you didn't care about specific errors. Okay, so in our error handling here, we have two different errors that we can get. Let me go back to the network manager and show you. So here where we're explicitly throwing a GF error, invalid username, GF error, invalid response, and that is of type GF error. But we can also, like I said, this throws is kind of like a catch-all errors. Like if this fails, for whatever reason, we're going to get just like the generic error, like the Swift error, right? Not a GF error. So that's why in our follower list VC, our GF errors are the ones we specifically like want control over. So that's why we need to do if let GF error equals error as, and we're casting it as a GF error. So that's when we throw our specific GF error. So that means we have our specific, invalid username, invalid data. That's our specific stuff. We want to do present basically this, what we have here, right? I'm going to uncomment this, right? We want to do this. I'm just going to copy and paste it because it's literally the same thing, except we don't have error.raw value. Ours is a GF error.raw value. So I'm going to switch that error with GF error right there. And then we'll go back to commenting this line so they're not confused and Xcode's not yelling at us. Now, what we want to do here is, so this is our specific error, and then in the else statement, right, if this isn't a GF error, if it's not one of our specific errors, we can throw like a generic error. And a generic error meaning like just the catch-all, like the unable to complete your request at this time. However, we don't have that. So there's two things I want to do with our errors before we move on. Is you notice we abstracted this on main thread into the error, and this was on the extension of our UI view controller. So extension UI view controller, see present GF alert on main thread, and this was us putting it there. We just did that to abstract it away. But remember, we no longer have to worry about this dispatch queue.main.async to go to the main thread. So we can simplify this. Instead of present GF alert on main thread, we can just say present GF alert, get rid of dispatch queue.main.async, get rid of that, get rid of the self, highlight this all, do a control I, clean it up a little bit there. So now that is just present GF alert. That's good. But we want to create another function that's going to be similar to this that's just present default error alert or something, right? This is our catch-all error. So I'll copy that. We'll say present default error, and we're not passing any specific string message title, right? We're going to hard code that because that's our default. So we can simplify that there. But you notice we got some errors, right? Because we were passing in the title, we were passing in the message, we were passing in the button title. Now we're actually going to hard code that. So for that reason, we'll put these on their own lines here. So for the title, we'll say, and again, this is just something super generic. Something went wrong. And then for this message, we'll say we were unable to complete your task at this time. Please try again. And then for the button title, we'll just say, okay, right? That is just, again, this is like our catch-all generic error, right? When we don't have a specific thing to tell the user, this is just our catch-all error. Ideally, we're giving them specific information, but worst case scenario, this is what we show. Okay, so back to the follower list VC, no longer present GF alert on main thread. This should just present GF alert. And then else, we'll say present default error. Do a command B to make sure everything's good. Okay, cool. So now this is us calling our function. And like I said, it just reads top to bottom. Give me my followers with the try await of our network call, update the UI dismiss loading view. In the catch block, this is if things go wrong with this. And then again, we're specifically handling our GF error. And if we don't get a GF error, we're presenting our default error. Now, this was a little long in our catch block because we have to differentiate between our specific errors and the normal errors. Another way to write this, and I want to point this out just to let you know that like, there are many different ways to like work with this. I don't want you to leave this course or this update thinking this is the only way to write your network calls, right? Again, we had to do it this way because we want to show specific errors. Well, let's say you didn't want to show specific errors. All you wanted to show was just a default error. You didn't care about being specific. I'm not saying that you're writing a bad app, but sometimes the situation doesn't call for you to be specific with the user. So in that case, you don't even have to mess with all this. Actually, before I forget, because I almost did, here we also have to call dismiss loading view, right? Because if we get an error, we still want to dismiss the loading view. But okay, so in this same task, I'm just going to comment that out, and we'll write a new one below it. And again, I'm leaving these commented ones here for educational purposes, but let me show you how I can simplify this. So if we didn't want to show a specific error, we can make our try optional, which will either give us the value of our array of followers or a nil. So again, if we get our array of followers, great, we'll update the UI. If we get a nil, we'll just present the generic error. So that can be guard let followers equals try with the optional, right? Await network manager.share.get followers for username and page. Cool. And then you say else. So this is where we would present default error and then return. And then now we have followers and we can do update UI with followers and then, dismiss loading view. We'll probably have to dismiss loading view in here as well. But you see now that all this right here got simplified to this because we don't care about the specific error. We're either going to get an array of followers or nil. If we get nil, just show a generic error. So again, the lesson here, I will just comment this out and then uncomment this because this is how we're actually going to do it. The lesson here is there's many different ways that you can write this depending on the situation. I showed you two of the more common ones, but again, this is part of your deep dive, more of your learning that you will use this base knowledge to continue on. So the quick run through of this function now, right? We call get followers, we show a loading view, then we go into a task, which is our concurrency context. So we can use our await here. In the do, we say, hey, let our followers equal the result of our network call. And then if that is successful, update the UI, dismiss loading view. All the success stuff happens in the do block. And if this throws an error, now we're in our catch block. And then in our catch block, we need to differentiate between our GF errors and then just the normal like Swift errors that get thrown. And we're handling that accordingly by presenting our GF alert or by presenting just a default error. And then we dismiss the loading view. So it reads top to bottom how things happen. You're not like jumping in and out of order. And I know that old way that we had down here, I'll uncomment it now, may not seem like you're jumping out of order that much because this is a pretty simple network call, but it's not uncommon to have like nested network calls. And now you're like going steps 1, 6, 4, 2. You're jumping all over the place when you have like some nested network calls. So just the context there. But yeah, that's the whole point of this, async await Swift concurrency. Remember, structured concurrency versus unstructured. Structured is in order. Unstructured, you're jumping all over the place, out of order. And then it basically abstracts away a lot of the errors. You notice we are not dealing with weak self. We are not dealing with making sure we're updating the UI on the main thread. That is all handled. And then in the network manager, we don't have to make sure we handle all the exit points. By making this throws, we kind of have that catch-all that we're going to throw an error like no matter what, right? We can't make a mistake. So that wraps up the initial video. I'm breaking it up into 2, so it's not a marathon video. That's the initial lesson. And the next video, I'm gonna move a little quicker, but it'll be review to where we refactor the rest of our network calls, right? Our get user info and then our download image. We'll refactor those pretty quickly as practice. But again, if you want the challenge, maybe before you watch that video, try to refactor them yourself and then watch the videos and see how you did.